Hello geometers, here we are again, and we're in section 3.1 still, and what we're going to learn to do today is how we identify pairs of angles that are formed by three lines. Alright, we talked about our learning goals last time. In the last video, we learned how you find, or how you describe the relationships between two lines or two planes in a three-dimensional space, and now you see the learning goal here in the second video for this section is to identify angle pairs formed by three lines. Now we're really working with vocabulary in this video, all right? And that's pretty much it. So there's lots of things that we're going to have to memorize. Not going to be difficult though. All right, well, angle pairs formed by three lines. Before we talk about angle pairs formed by three lines, how about we look at angle pairs that are formed by two lines just for refresher's sake. Whenever we were looking at a situation where you had two lines that intersect one another, all right, there's two lines that intersect one another, well, they would always form four angles at their intersection, right? At their point that they intersect. And there were two types of angle pairs that were formed. All right, for instance, you know that angle 1 and angle 3 are vertical angles, right? So, one type of angle pair formed by two lines are vertical angles. And of course, then the other type of angle pair that was formed by by two lines intersecting were linear pairs, right? For instance, angle 1 and angle 4 form a linear pair. Angle 4 and angle 3 form a linear pair. Every time you have two lines intersect, there ends up being four linear pairs that are formed. Alright, well in this video, we're not concerned anymore with what happens when two lines intersect. We're concerned with what happens when three lines intersect. Alright, or at least that's the new thing that we're learning. So let's look at angle pairs formed by three lines. Okay, now something I want to point out to you real quick is when you have three lines, such as what you see in this picture, in order for them to form any angles at all, some of those lines have to intersect one another, right? And in this case, if I continued drawing these two forever, they would all three intersect one another. That's irrelevant, but I have two lines that are both being intersected by the same line. Alright, well, some vocabulary I need you to know. Whenever you have two lines that are intersected by the same line, one of the vocabulary terms you need to know is that one line that cuts through the other two is called a transversal. Alright, let me label that. Alright, supposing that these lines are lines A, B, and C, C is called a transversal. And whenever a transversal intersects two other lines, do you see how many angle pairs are formed? Alright, well, let's count them. We got four angles formed at the intersection of line A with line C. Let me make that C a little bit more clear. And we've also got four angles that are formed by the intersection of line B with line C. So there's a total of 8 angles altogether. And what we're going to try to do is this. We're going to try to compare angles that are formed where line C intersects each of these lines A and B. Alright, if you ignore line B for a moment, if you just look at one of the intersections, like say right here for instance, you still have vertical angles, right? 1 and 3 and 2 and 4, and you still have linear pairs, 1 and 2, 2 and 3, and so forth. Alright, same thing down here, vertical angles and linear pairs. So we're not just looking at where two of the lines intersect. What we want to do is compare the angles at this intersection with the angles at this intersection. Alright, well, there's several names that you got to know, as I told you, and let's start kind of going through the list. The first type of angle pair I want to talk about that's formed when three lines intersect or when two lines are cut by a transversal are what are called corresponding angles. And the thing about corresponding angles that makes them corresponding angles is that they are angles in what are in corresponding positions at the two intersections formed by that transversal with those two lines. And what I mean by corresponding positions. Alright, well, angle 1, do you see how that's the top left angle where line A intersects C? And then angle 5 is the top left angle where line B intersects line C. Well, since they're both the top left angle with their respective intersections, that means they're in corresponding positions, and so they're corresponding angles. Alright, so I'm going to list the corresponding angles here. Angle 1 and angle 5. There and there. They're in corresponding positions. Alright, what's another pair of corresponding angles that you see? Alright, well, how about angle 4 and angle 8? They're both the lower left angle at their respective intersections, so they're going to be corresponding angles. As are angles 2 and 6, they're the top right angles at their respective intersections. And then, of course, angle 3 and angle 7, which are the lower right angles at their respective intersections. Alright, that's corresponding angles. But there are some other types of angle pairs that I need you to know about. So, let's shift gears a little bit. The next thing I want to talk to you about are what are called alternate interior angles. Okay, now in order to understand what alternate interior angles are, you've got to be able to break down that term, alternate and interior. Alright, those have special meanings for whenever you have these two lines being cut by a transversal. Alright, now let's start with the interior part. Okay, when we're talking about interior angles, when you have three lines like this, we're talking about the angles that are between the two lines being cut by the transversal. So I'm going to highlight this. This would be considered the interior of those two lines being cut by a transversal. Alright, and then when we're talking about alternate, well, the alternate portion refers to the fact that one of the angles in this pair is on one side of the transversal and the other angle is on the other side of the transversal. So we got to look at the transversal C, okay? And whenever we're doing that, alternate interior angles have to be on different sides of the transversal. Alright, one more kind of important point with this. Angle 4 and angle 3 kind of fit the description that I just said, don't they? Because they're both interior angles in this picture, and one's on the left side, one's on the right side of the transversal. But aren't those a linear pair? Okay, what we need to do with all the new angle pairs that we're trying to learn today is we need to compare one angle where the transversal intersects one line to an angle where that same transversal intersects a different line. So I got to pick one angle from up here and one angle from down there, and they have to be on alternate sides of the transversal, which means that angle 4 and angle 6 will be alternate interior angles. Let me make this picture a little bit cleaner so I can show you that. Alright, angle 4 and angle 6 on the interior of the two lines being cut by transversal on alternate sides of the transversal. And there's only one more pair of angles that fits that description. The other two alternate interior angles have to be angles 3 and 5. Alright, so there's alternate interior angles. On to the next type of angle pair. Corresponding angles are out of the way. Alternate interior angles are out of the way. The next type of angle pair we're going to talk about are alternate exterior angles. And I bet you've got a pretty good idea of what alternate exterior angles would be already, but I'm going to illustrate it for you nonetheless. Alright, so you understood what alternate interior angles are. I think, as I said, you've probably got to guess about what alternate exterior angles are. So we're still talking about angles where one of the angles has to be on the left side of the transversal, and the other angle in the pair has to be on the right side of the transversal, or above or below if the lines are facing a different way. But anyway, on alternate sides of the transversal. But when we're talking about exterior angles, well, the exterior angles have to be outside of the two lines being cut by the transversal. Let me highlight the exterior angles. Alright, these are exterior angles, These are exterior angles. All right, now whose cell phone is ringing in the middle of class? Oh wait, that was mine, my fault. Okay, anyway, so alternate exterior angles. Well, what do you think an alternate exterior angle pair would be in this picture? I'm hoping you would say this. How about angles 1 and 7? They're on different sides of the transversal C, and they're outside of the two lines A and B. All right, and then angle 2 and angle 8, of course, would be the other pair of alternate exterior angles. All right, so that's corresponding angles, alternate interior angles, and alternate exterior angles. There's two more types of angle pairs we could talk about, but one more that is really going to be relevant to you. And that other type of angle pair that's going to be relevant to you are what are called consecutive or same side interior angles. Let's take a look. All right, so we're back at talking about interior angles, so the angles that are between the two lines A and B. But when we're talking about consecutive or same side angles, we're talking about angles now that are on the same side of the transversal as one another. So, for instance, angles 1, 4, 5, and 8 are all on the left side of the transversal. 2, 3, 6, and 7 are all on the right side of the transversal. So those sets would be same side angles. And it's just a matter of whether you're talking about interior or exterior at that point. Now, when we're talking about consecutive interior angles, I again want one angle at this intersection and another angle at that intersection. I don't want to choose the linear pairs 1 and 4. We already know what linear pairs are. We're going to be learning about the consecutive interior angles. And, well, that leaves us with angle 4 and 5 as consecutive interior angles, right? And then, of course, the other pair of consecutive interior angles in the picture would be angles 3 and 6. Now, the other type of angle pair that we didn't talk about were consecutive exterior angles, which would be like angle 1 and 8, or angle 2 and angle 7. But we don't really have to worry too much about consecutive exterior angles, excuse me. But corresponding angles, alternate interior angles, alternate exterior angles, and consecutive interior angles are all terms that you need to be very, very familiar with, and you need to be able to identify such angle pairs at any time when you have 3 or more lines that are intersecting one another in some combination. All right, excellent. That's our video. We'll see you in class.